Let's practice finding domain and range from graphical representations. The key to finding domain and range from a graph is to remember that whenever you are finding your domain, you're focused on going from left to right, versus whenever you are finding your range, you're focused on going from the bottom to the top. Okay, so starting with our domain, we want to identify left to right, so starting with the left, the smallest possible value on this graph. So going to the left, I notice that my graph stops right here. That's my smallest x value. And then going to the right, I notice that it goes to this point. So let's identify those numbers. Going from the origin, I see that going to the left, I'm at -1, 2, 3, 4, 5, 6, 7. That's -7. And then my largest possible value going from the origin is 1, 2, 3, 4, 5. Okay, domain is our x value. So my x is going to go in the center. And then I want to identify my inequalities. Okay, we always know that the number on the left is going to be less than our domain, and the number on the right is going to be greater than. So we always point our inequality signs to the left. However, next we need to identify if they're going to have an or equals to. So looking on the left-hand side of our graph, do you see how this dot is actually closed in? That means -7 is included in our domain, so it's going to have an or equals to. Versus on the right-hand side, do you see how the circle remained open? That means 5 is not included. It goes all the way up to 4.999999, but it never actually touches 5. So we are not going to have an or equals to whenever we are referencing our domain to the 5. So that means that our domain is -7 is less than or equal to x, which is less than 5. Let's move on to the range. So for the range, we're actually starting from the bottom and moving up, because our range refers to our outputs or our y values. And since we start with the smallest value, that's why we're going down first. So from the origin, when I'm moving down, I notice it goes down to this point. And then moving up, I see that it goes to that point. And now I'm ready to put some numbers to that. So our smallest value from the origin appears to be -3. Our largest value from the origin is +1. We're talking about our range, so our y goes in the center. Again, -3 is the smallest, so it's less than. And 1 is the greatest, and so it is greater than y. I know I did a less than symbol, but that's because 1 is on the right. So if I read that backwards, it says 1 is greater than y. So then next, again, I need to identify if I'm going to include those or equals to. You'll see that our value for -3 is actually closed in, therefore it is included, versus our 1 is an open circle, so it is not. So our range would be -3 is less than or equal to y, which is less than 1. Moving on. Again, we want to identify our domain and our range. Domain is left to right. I notice from the origin, it does not actually go further to the left, so 0 is our starting point. And then for our maximum value, this has an arrow on it, which means it's going to continue to go on and on and on and on forever and ever. It never stops. So that means that our domain is actually every number that is greater than or equal to 0, because that's a solid line touching the 0. So our domain is going to be our x is greater than or equal to 0. Similarly with the range, this time we're going from the bottom and going up. I see the lowest possible value on the y-axis is also 0. And even though this looks like it's trailing off to the right, it also is slowly increasing over and over and over. Therefore, it never stops going up, which means that our range is also every single number that is greater than or equal to 0. So our y is greater than or equal to 0. Okay, we've got one more example. This time we have a parabola. It's that U shape. So for our domain, again, we're looking left to right. So moving to the left, that arrow is going to continue to go on and on forever and ever. Moving to the right, This arrow is going to continue to go on and on forever. That means every single number that exists is part of our domain. So we actually say that our domain is all real numbers. We have to say the word all real numbers because that includes our natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Every number that exists is going to be covered in our domain. It's touching every single value because that arrow continues to go on forever. Now, our range. So looking at our y-axis, if I'm moving down, the lowest possible number is on the y-axis 0. But then moving up, again, those arrows go on forever and ever. So the largest possible number, it doesn't exist. This graph is going to continue going on and on. That means that our range is going to be every single number greater than or equal to 0. The reason it's not all real numbers is because it does have a lowest point or a minimum value. The lowest point on the y-axis is 0, but it then goes on forever and ever above that.